Hello again. So I last stopped right before I went on to do some examples of models that you can build using R. So that is what I'm going to do now. So previously I showed that you can do plotting and user-defined functions and loops. And here's now I'm going to do some examples of modeling predictions that you can do. So here I'm going to build a linear model that's going to predict the team score using the opponent's score, first downs, other stats like that. So you can see if I do that, doing a summary of the model, I can analyze what the model is showing. So for example, we see that it starts with an intercept of -5, and these are all the various other coefficients for the variables. And in terms of residuals, so that's the error, the highest misses are 27 above and -25 below the predicted value. So it's not going to be very accurate, but it's something. The R-squared value is 0.59, so it's not 0. But it's not a perfect model, but it's something to get us going. So that's to predict the actual team score. Now if I look at point spread, I will do that by running these lines here. And then creating a model using all these differences. So predict the score difference in terms of first down differences, passing yard differences, rushing yard differences, etc. And looking at that model, we can see that it misses by even more above and below, but it actually has a higher R-squared value. So it's 0.67, so that means it's doing a better job of explaining all of the values in terms of the predicted variables. So that's for what it's worth. Now I can do some more plotting. So here I'm going to plot the residuals just to show that you can do so. So you see over here, these are all the residuals. If it was not biased at all, the residuals would fall all along the red line. But it's not, and that means that our model isn't probably doing the best job. One of the reasons might be because a linear model might not be the best way to do this modeling. So now, continue moving on. When I first did this presentation, the Seahawks were going to play the Raiders, so I was going to offer a prediction of the next game. So I can show you what was going on there. So I load the team data, for the year 2014, and then I do the same for the Raiders. Now I'm just going to calculate the score differences and build a model based on that. So calculate this, the differences between each team's first downs, passing yards, rushing yards, total turnovers, and use those values and then put them into the model that we had created to try to generate a predicted score. So by plugging it into the score difference model, it predicts a score difference of 12.46, or when I originally did this it was 10 points. So it was predicting that the Seahawks would win by 10 points. And now if we want to go to final score, I'm going to use all of the data to build a final team score prediction. So that's what I'm doing here. And what I'm doing is using the coefficients from the model and multiplying it by the team score, and then I'm actually using averages to try to do weighted averages to make the model perform better. But all you need to know is really I'm just multiplying and adding up all of the different variables that we gathered to try to use to predict the team score. So I do that here, and then it gives me a predicted team score, so that'd be what the Seahawks are supposed to get of 28. And if I do the same for the Raiders, then I get that the Raiders are supposed to score 12 points approximately, or when I originally did this it was 16. So the original prediction was 28 to 17. So I was supposed to predict that the Seahawks win. Now, did the Seahawks win? Yes, we can see that the Seahawks won 30 to 24. So it did correctly predict that the Seahawks won, but obviously it wasn't exactly the correct score. But some errors to be expected. But now we can start looking at, okay, well, is this model good? Is it predicting very well, or we need to assess the model. So when I originally did this, I ran the prediction and then got the actual value. And here are some examples. Week 1, Seahawks beat Green Bay 30 to 21. It predicted that Seattle would win 36 to 16. Second week predicted that Seattle would lose to San Diego 24 to 23, and San Diego won 30 to 21. So you can see, it's doing all right. As we scroll down, a lot of predictions are off, or there's a wide variance in the scores. So at that time, the correct outcome was, in terms of wins and losses, was 3 out of 7. So you might as well have just flipped a coin to predict the winner or the loser of the game. And the problem is shown here, where the average of the residuals of the model is 5.2. So that means on average the prediction is missing by 5 above or below. So when the score of a game was within 10 points, the difference is within 10 points, it meant that the model was not going to be very accurate, because it's likely going to be off. And for close games, it just means you're not going to be able to tell who's going to win the game. So it wasn't very good in terms of predicting the final outcome, win or loss. But most of the time the predictions were within 7 points of the actual score. So just means that this model needs to be improved, which is fine because this is just a demonstration. So here's some thoughts about how I would go about improving this model. I would add more data, like passing completion by the quarterback. How often the quarterback completes is probably going to be important, or the number of third down conversions, or field goals, or touchdowns, etc. You can add all kinds of data and make the model better. We could use different kinds of models, nonlinear models, for example. There might not be a linear relationship going on, so we would need to determine if these models perform any better. And then you could use this data set to make other sorts of predictions apart from the final team score and score difference. You could use it to predict whether a team will make the playoffs or win the Super Bowl. You could do some other descriptions, descriptive statistics like ranking teams from best to worst or players by position. So really you can use R to do all kinds of things. And so this is just an example of the sorts of possibilities that are out there for what you can do. So that is my conclusion. Since this is a video, I can't take any questions, but if you want to post something, feel free to do so. Thanks for listening, and I hope that this was insightful. Thanks. Bye.